The atoms of some elements can exist independently. For example, helium or neon. They are known as monoatomic elements. Their chemical formula is same as their chemical symbol. Helium He and hydrogen H, neon Ne. However, the atoms of many elements can't exist independently in nature. They form molecules containing two or more atoms. For example, molecules of hydrogen, nitrogen, oxygen, and chlorine have two atoms each. So they are known as the diatomic elements. Why it is so? Because they have the one valence electron in their outermost shell and they have to complete their valency. So they can't exist monocally. So they make the bond with the other atom with the same atom and exist diatomically. Thus hydrogen represent a molecule, H2 represent a molecule of hydrogen, N2 a molecule of nitrogen, O2 a molecule of oxygen. Now it is not an atom, it's a molecule because two atoms combine together and make a molecule. Cl2 molecule of chlorine and Br2 molecule of bromine and I2 molecule of iodine. The number of atoms present in a molecule of an atom of an element is known as its atomicity. The number of atoms present in a molecule, like in a molecule of hydrogen, number of atoms are 2. So this is known as its atomicity. So the atomicity of hydrogen is 2, iodine is 2, oxygen atomicity is 2. A formula tells us like water is made up of two elements as we have discussed earlier, that hydrogen and oxygen. So thus the formula of a compound tells us the types of elements present in a compound, means how many types of elements are present in a compound. In water there are two types of elements, oxygen and hydrogen. And a molecule of water contains two atoms of hydrogen and one atom of oxygen. So formula tells us that how many atoms of each element are present in the compound, means two atoms of hydrogen and one atom of oxygen. Now H2O represents one molecule of water. The formula represents the molecule of the compound, means how many molecules are present there. But if we write 2H2O, there are two molecules of water. And if we write 5H2O, it means 5 molecules of water, as shown below. Now, the valency of an element or a group denotes its combining capacity. How an element combine to another element? The valency of hydrogen is 1. The valency of the hydrogen atom is 1, and the valency of the other elements groups is the number of hydrogen atom which can combine with the or displaced by one atom of that element. So some elements neither combine with the hydrogen nor displace it. In such cases, we consider their combining capacity with some other elements whose valency with respect to hydrogen is known. For example, zinc combines with oxygen to give zinc oxide, and it has a formula ZnO, since one atom of zinc combined with one atom of oxygen. So the valency of the zinc and oxygen are same. So the valency of, because the valency of the oxygen is 2 and zinc has also 2. So this is the valency, means the capacity or the tendency of an element to combine with the other element. How to write the formula. Now the symbols of the elements or groups it is made up of, and the valency of the elements and group it is made up of. These things should be kept in mind. Only after then we are able to write the formula. We have to follow the steps like write the symbol of the elements side by side. We have to write the symbol, like we have to write the formula for NH3, and now we will write the symbol of nitrogen, that is N. After that we will write the symbol of hydrogen, that is H. The valency of nitrogen is 3 and that is hydrogen of 1, and so 3 atoms of hydrogen will combine with 1 atom of nitrogen. The valency of nitrogen is 3, it is written, and valency of hydrogen is 1. Then we have to interchange the numbers obtained and write them at the bases as subscript to get the formula, like we write here. Now interchange the valencies and writing them as a subscript, we get the formula of ammonia, like NH3. So 1 atom of nitrogen combined with 3 atoms of hydrogen, they complete their outermost shell and make the bond with each other, and we get ammonia, NH3. This is how we can write the formula, and like this we can write the other formulas also, like iron plus sulfur, iron sulfide, and many more. Now we have to balance the equation. We not only have to make the chemical equation, but it is only right when we balance it. The left hand side is would be equal to the right hand side. So the chemical equation shows the result of a chemical reaction in which the reactants and the products are represented by the symbols or formulas. Between the reactants and products, we place the sign arrow. If there are more than one reactants, we will put the sign of plus, as we do in the example. And we have the nitrogen reacts with hydrogen to give the ammonia. We take the 2 atoms of nitrogen, or we can say that a molecule of nitrogen plus molecule of hydrogen, and it gives us the ammonia, NH3. And we use the sign arrow between the reactants and the products, as the reactants are nitrogen and hydrogen and the product is ammonia. The reactants are written on the left hand side, as you can see that nitrogen and hydrogen is on your left hand and product is written on the right hand side. These three are the basic rules to write a chemical equation. Means we have to put the sign of arrow between the reactant and products. The reactant should be written on the left hand side and the product should be written on the right hand side. So this equation gives us nitrogen reacts with hydrogen to give the ammonia. In the first equation you can see N2 plus H2, it gives us NH3. Now count the number of molecules on the both sides, number of atoms on the both sides. In the left hand side we have 2 atoms of nitrogen and 2 atoms of hydrogen, but on the right hand side, on the product side, you can see we have only 1 atom of nitrogen and 3 atoms of hydrogen. So left hand side is not equal to right hand side. It means our equation is not balanced. We have to balance it. And how we can balance it? We have to make the number of atoms on the both sides equal. So now count the number of hydrogen atom. These are 3 and nitrogen 2. So first of all, we will write the 2 in front of the N. So on the right hand side, we write 2. We get 2 nitrogen on the left hand side and 2 nitrogen on the right hand side. Our nitrogen atom is now balanced. Now, when we write 2 in the product side, we get 6 atoms of hydrogen. 2 3s are 6. These will get multiplied. We have already 3 atoms of hydrogen, and now we write 2 on again in front of an nitrogen. So these are the, it becomes the 6. So now on the left hand side, we have to make the hydrogen 6. What we do? We multiply the hydrogen with 3. So now count the number of atoms on both sides. And 2 on the right hand side, we have an number of atoms of nitrogen 2. On the left hand side, we have 6 number of hydrogens. 3 2s are 6 atoms of hydrogen. On the right hand side, 2 3s are 6. We have the 6 hydrogen atom. So now the equation is balanced. And this is, we can say that the left hand side is equals to right hand side. And this is a balanced chemical equation, and it is right. The imbalanced chemical equation is not right. So this is the correct form of chemical equation. Thank you.